Up to now, we've been pretty Windows-centric. Most of the time, we're talking about Windows. But now we're going to talk about a non-Windows operating system. Most of the Linux that you see runs on servers. There are some people that run Linux as a end-user workstation, but there's also a lot of Linux running that people don't know about that's not necessarily servers, and that's what? There's a lot of embedded Linux systems that are running around where Linux is under the covers, but you never see it. Some routers are Linux-based, right? A lot of automated, controls now are Linux-based. If you go and you get a cable box, you get a DVR, you get some other kind of box for your television set. A lot of times it's running a Linux operating system. A lot of instrumentation are things that come with computers installed or included as part of them. They'll use Linux because they don't have to pay for the licensing on the one hand, right? But in some cases, because Linux is easy to strip down, right, and embed in firmware and include in the device. Now, there are also embedded versions of Windows. There's a Windows Embedded XP, and I believe there's also an embedded version of Vista and Windows 7 now as well.
Where are those being used?
Siemens, Honeywell, other people that build, building controls and processes, sensors, and other types of controls for heavy machinery and medical equipment and all that. They'll use embedded Windows versions. I've also, go ahead. Okay. Oh, okay. Have you ever seen those kiosk screens that they put in? And and microwave ovens and everything. So, for the most part, a lot of this also applies to Unix and Mac OS, since they share the same basic, operating system structure. They share the same basic process structure, file structure, directory structure. They differ sometimes in how they do memory management. Mac OS is not totally a monolithic kernel. It's based on multiple kernel processes and Darwin. Very similar to like Mach, M-A-C-H, which was a CMU operating system. But Unix and Linux are typically monolithic kernels. You've got one image running inside the kernel. There are some Unix-like operating systems where they actually break that up and they have different processes running as the task scheduler, the memory manager, the file I/O manager, etc. So we're going to look at Linux, some basic Linux and Unix commands, the shell, the file structure, how you compile programs on Linux, and we'll talk about Linux security and then its vulnerabilities. And then we'll also talk about using it as a security platform, because a lot of security people use Linux as their platform for going out and scanning and doing assessments, right, and doing network penetration testing. Not everybody uses Windows. Windows does have whole sets of tools for using it, and if you want to run Core, you have to run what? Windows, because Core only runs on Windows. But there are network penetration tool sets that run on Linux as well and other OSs. Metasploit runs on Mac OS and runs on Linux, right? Canvas runs on Mac OS and Linux, right? Mm-hmm. Metasploit at least used to be completely open source, and Core is completely proprietary, but Canvas was somewhere in the middle where there was a big community and they actually contributed to it, but it was still a commercial product from ImmunitySec. Now this says the majority of servers around the globe are running on Linux or Unix-like platforms. I think that might be debatable. I bet it's more like 50-50 Windows and 50-50 LAMP platforms. So you got your two basic server communities in the world. Those people that are running Windows Server with IIS, like Windows 2003 or 2008 usually, and then you've got the people that are in the LAMP platform community, right? They're running Linux, Apache, MySQL, PHP, or variants thereof. Right? Linux is easy to get and easy on the wallet, but that's not your total cost of ownership with Linux, right? What else do you have to think about? Maintenance. You've got to think about administration. You've got to think about other things. Now, sometimes today that can be highly automated. There's a lot of ways to really leverage lots and lots of Linux virtual machines running on blades and server farms, and you can do it pretty cheaply. But a lot of times people don't bring in Linux because they're afraid of what? They don't have anybody that knows Linux, right? And all their people know Windows and they know how to use it from the GUI. So that's why a lot of sites go with Windows Server, because they have people that know Windows, they know where they can get people that know Windows. They can even find a reasonable number of people that are certified in Windows as Microsoft certifications, etc. It's much tougher to do that with Linux. I have seen some companies that are always looking for Linux sysadmin people, So if you know Linux pretty well, usually you can get a job pretty easily. I've been getting emails that says HostGator is looking for Linux sysadmins, Another big problem with Linux is, as with many standards, there's so many, it's nice to choose from. There's a lot of different Linux distros, right? And they're each slightly different than the other. Now, if you know Linux, usually you can do, you can handle each one of the distributions, but they package up all of the system administration functions slightly differently. So some of them use different methods for distributing the packages, right? What does Red Hat use?
RPMs.
Right? What does SUSE use?
RPMs.
What does Ubuntu use? Yeah.
Devs.
Right. So there's others there. And then, there's a much smaller variants, sometimes that are specialized just for particular market segments, right? Source code is available. That's a good thing. Means that if you want to, you can modify the source code, you can improve it, you can fix it, or you can do something unique that you want to do. But it also means that people get to look at the source code so that they can find vulnerabilities. Now, there's always this debate in the security community about which is more secure, Windows or Linux. It's like religions, whatever. There's pros and cons to each approach. Sometimes they complain and say, well, you put the source code out there, people can find security holes in it. Well, yeah, but it also means that they can find them and fix them faster, right? Because there's a number of people looking at them. In the proprietary world like Microsoft, you don't get the source code. Actually, there's some people that do get the source code, but not the major community. But people are finding security holes all the time anyway, because it's possible to, fuzz and black box Microsoft Windows and find holes in it. And you can still find buffer overflows. You don't need to look at the source code to do that, right?